what's the deal with counting? Counting, it teaches basic number structure of our whole number system. So it's the foundation, the bottom layer of foundation of our whole number system, and mathematics is built on our number system. Your brain processes numbers in three different ways. You have a verbal, a symbolic, and a quantitative. All three of those are taught beginning with counting. So many people think that, well, counting is just natural because they don't actually remember learning it because you learn it at a really young age. So like 2, 3, 4, 5, that's when you learn how to count. But counting must be taught directly, and it has to be repeated at higher and higher levels of difficulty in order for you to have a really strong foundation in mathematics. So counting is the most important skill because it's the basis of adding and subtracting and multiplying and dividing. The higher you are able to count, you also learn the names of numbers, the categories of numbers such as hundreds and thousands and 10,000s, and then backwards as well, learning to go up the number line and back down the number line. That's the counting skills that are needed for your basic understanding of adding and subtracting and multiplying and dividing and on from there. So with adding, counting is the first step to learning adding. So the first level is going from 0 to 10, forwards and then also backwards. But that's how you learn to add things like 7 plus 3. In my tutoring experiences, there are a lot of students who cannot add single-digit numbers without counting on their fingers. So that means that their counting abilities has not been mastered enough for them to just know what 3 plus 4 is, or 2 plus 5 is. The first level, going from 0 actually all the way to 20, is your basis of adding all numbers, because 9 plus 9 is 18, and if you know that 9 plus 9 is 18, then you know that 29 plus 9 is going to end in an 8, just like 18. So that knowledge comes from your basis of learning to count forward. Third level is hundreds and beyond, and understanding how big numbers are, how many hundreds it takes to make 1,000, being able to count by hundreds, being able to count by tens, being able to count by thousands, and begin from any number on the number line and being able to count up is basically what adding is. It's also being able to visualize a total with something being added to it, and understanding that adding is combining two things together. The ability to count backwards is your first step in learning how to subtract. First, being able to count from 10 back down to 0 fluently, quickly, instinctually, and then being able to count from 20 all the way back down to 0. Again, fluidly and instinctually is where subtraction comes from. And if you can do that well, then you can also learn how to count backwards from 100 because it's the basically similar pattern from 20 back down to 0. And subtracting from 100 or any two-digit number is basically the same as subtracting any numbers between 0 and 20 because the ones digit will have this similar outcome. And then when you're subtracting other place values, it's the same as subtracting single-digit numbers. Your third level is being able to count backwards from numbers that are beyond 100 and back down, and understanding the complexity of your higher number system going backwards. Also, being able to count backwards teaches your mind to visualize a total with something being removed, which is basically what subtraction is. Skip counting is like baby multiplication. First level is being able to count by 2s and by 5s and by 10s and by hundreds. And it is extremely important because not only is it important for multiplication, but it's also important for higher level adding. Like, what's 100 plus 100? Well, if you can count by 100s, then you can be able to figure that out. What's 100 plus 400? Well, 100, 200, 300, 400, 500. And you're able to add and subtract based on your ability to skip count higher, going up, and skip count lower, going backward. The secondary level would be being able to count by 3s and 4s. Your third level is being able to count by 6 and by 8, based on being able to count by 3 and 4. Because your 6s are every other 3. So 3, 6, 9, 12. 3, 6, 9, 12. Your 6s are 6, 12, 18, 24. It's every other 3. And the same with your 8s. Your 8s is every other 4. So 4s go 4, 8, 12, 16, 20. Your 8s go 8, 16, 24, it's every other 4. So if you know your 4s well, then you can get your 8s easier. If you know your 3s well, you can remember your 6s easier. Skip counting also plays into quick visual counting. So if you're counting objects, and there's a lot of objects there, if you're counting by 1s, it's not going to be very efficient. But if you count by 2s or 3s or even 5s, then it goes much faster. Counting also plays a huge role in understanding fractions, because fractions are basically just pieces, and your numerator is the number of pieces and the denominator is the size of the pieces. So it's like a unit. So how many of this size do we have? How many of that size do we have? So your first level is just counting your pieces. 1/2, 2 halves, 3 halves, 4 halves. 1/3, 2/3, 3/3, 4/3, 5/3, and just understanding that you are counting pieces. Second level is being able to add unit fractions. So like 1/3 plus 1/3. 1 plus 1 is 2, so 1/3 plus 1/3 is 2/3. Very similar to your basis of adding. In fact, it's the same. Third level is to add non-unit fractions by counting on. So if I have 2/7 and I want to add 3/7, well, 2, 3, 4, 5, 5/7. Same as just regular adding. Fourth level, you're trying to count pieces that are not the same size, and you figure out quickly because of your counting skills that you can't do it because they're not the same size. And then that leads into understanding why you need to have a common denominator when you're adding. And subtracting fractions works the same way because you are taking away some of those pieces. So you are counting backwards by pieces. Counting also plays a part in understanding equal fractions because there is a pattern you can see in equal fractions that can help you recognize when two fractions are equal. There are other aspects of equal fractions that also must be taught, but this particular understanding of this pattern can help to visually see equal fractions. So when you begin with a unit fraction like 1/2, and you can see all of the fractions that are equal to it will fall into this pattern, unless they have like a decimal for a numerator or a denominator like 1.5. Then they would be between these. But these are your basic ones. And you notice that the numerators are all following the sequence of just counting. But the denominator are all counting by 2 because the unit fraction is 2. So 2/4, 3/6, 4/8. Those are all fit into the same pattern. And when kids see this pattern, they understand visually how to recognize when a number or when a fraction is equal to 1/2 because they recognize that it would be in the pattern. Or they recognize that the denominator is twice as big as the numerator every time. It also works with non-unit fractions like 2/3. 2/3 is a non-unit fraction because it has a 2 in the numerator instead of a 1. That's all it means. But you'll notice the 2 in the numerator, your numerators of all your equivalent fractions to 2/3 all count by 2s. And then your denominators all count by 3s. Seeing these patterns can help students understand, multiply the top and the bottom by the same number. You can see it here. Same with the 1/2. You can see the pattern that helps you recognize equal fractions. It also works with improper fractions like 4/3. So the numerators would all count by 4 and the denominators would count by 3. But it also helps you to recognize fractions that are not the same size or are not equivalent because they don't fit the pattern. Like this. So you have the pattern of 1/2 and you have all of the equal halves. Well, then you take the fraction 10/21 or 10/21. Would it be equivalent to 1/2? No, because the sequence goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be on the top, but on the bottom 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 would be on the bottom. So counting actually plays quite a big role in understanding equivalent fractions as well. Link 6 is counting decimals and understanding our base 10 number system. Base 10 because we have 10 fingers. First level is just understanding place values that are 1s or greater. So 1s, 10s, 100s, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, and that pattern is all counting. Your second level would be counting numbers that are between 0 and 1, or bits and pieces, decimals, numbers that are to the right of the decimal place. Counting tenths, 1/10, 2/10, 3/10, very similar to counting fractions. And the same thing with hundredths, counting 1/100th, 2/100th, 3/100ths, 4/100ths, on up to like 27/100ths, 28/100ths, 98/100ths, 99/100ths, and then you have 100/100ths. What would that be? It also leads into counting coins and counting money because you're counting groups of decimals. 0.25, 0.25, or 25/100ths and 25/100ths is 50/100ths. Link number 7 is integers. Your understanding of integers is based on your ability to count things that are alike. So for instance, your first level is just counting negatives with negatives. So if I have 3 negatives and I have 3 more negatives, then I have 6 negatives because I can count. And then the same, because it works the same as with positives and positives. If I have 3 positives and 3 positives, then I have 6 positives. That's the first level. Second level is adding positives and negatives together. So if I have 3 negatives and I have 3 positives, what happens? Higher levels go into multiplying repeated groups of negatives. So -3 and -3 and -3 and -3 would be -3 4 times. Again, it's all counting. Link number 8 is understanding consecutive number equations. And consecutive numbers are just numbers that are right next to each other when you're counting. 51, 52, 53. Those are all consecutive numbers. And understanding that if x is the first number in a consecutive number sequence, then the next one would be x plus 1. So if 50 was my first one, then 50 plus 1, or 51, is my second one. And 50 plus 2, or 52, is my third one. Link number 9 has to do with coefficients and like terms. A coefficient simply tells you how many of the thing that you have. So for instance, if you're talking kindergarten level, if I have 3 apples, 3 is my coefficient because I have 3 times apples, or an apple 3 times. As you get higher, you start looking at repeating numbers. So 3 times 2 means I have 3 2s, which makes 6. Then as you get into algebra, you have missing numbers. If I have 3 times x, that means I have 3 x's, which is x plus x plus x. And then as you get into distributive property, you understand that 3 times x plus 1 means you have 3 x plus 1s, or you have x plus 1 and x plus 1 and x plus 1. 3 times, which means you have 3 x's and 3 1's, which is 3x plus 3. Being able to count well also links to understanding greater than and less than. So your first level is just understanding if a number is higher or lower than another number, but also before or after another number. That's a term that I found that several students got confused. If a number is after it, it's higher than it. If a number is before it, it's lower than it. And then you go into the decimal range and what decimal is before this one, what decimal is after this one. And then you also have fractions. Which fraction is bigger? Which fraction is lesser? Is it greater? Does it have more bigger pieces compared to fewer small pieces? Or do you have fewer big pieces and more small pieces? And then you start looking at unlike fractions. And is this fraction close to 0 or is this fraction close to 1? Students who understand counting from 1 to 10 really, really well can visualize it in their mind without being shown it. But if you don't understand counting from 1 to 10 really, really well, then sometimes you just memorize rules, and those rules actually make no sense to you. Your first level is just knowing the numbers from 1 to 10. Is 8 closer to the beginning of that or closer to the end? If it's closer to the end, then it's closer to 10. And then you understand that 5 is the exact halfway point. So if any number is above 5, it's going to be closer to the next 10. If it's below 5, it's going to be closer to the 10 that is before it. Your second level on that is fractions that are close to 0 or close to 1 and understanding the fullness of a fraction. And then moving into number fractions that are between your other numbers, like between 1 and 2, between 10 and 11, and between 23 and 24. Is it closer to 23? Is it closer to 24? That all has to do with counting and understanding more and less. And your decimals are basically the same. That's why the rule of 5 and up, round up, works, because those numbers in the sequence of 1 to 10, 5, 6, 7, 8, 9 are closer to 10. The last link I've chosen to highlight here, and there are others, I had to decide which ones to put in and which ones to leave out, would be understanding sequences and series. And patterns we've already talked about. Students understand patterns and sequences. Well, that goes all the way up into Algebra 2, where you start describing these patterns using equations. Level 1 is just recognizing when numbers make a pattern. 1, 3, 5, 7, 9, 11, 13, those make a pattern. Can the student recognize the pattern? If they can count from 1 to 20 really, really well, like they've got it mastered, and 1 to 100 really, really well, they've got it mastered, they can see these patterns, how far apart they are, much easier. Second level is being able to continue the pattern on past what's written in the one that you're looking at. Third is being able to describe how a pattern is progressing using an equation. So that gets into your terms and your term numbers. It's progressing by adding 2 to the one before it. It's basically what that is. Level 4 is looking at summation. So if I add up this entire series or this entire sequence, what would it add up to? And that gets into some pretty high-level math, but it all boils down to being able to understand and recognize a pattern based on being able to count. So as you can see, the connection from counting goes all through math. It is the basic level of understanding. And literally all other math is built upon being able to understand the sequence of the numbers and how they progress, which is counting. Every teacher at every level creates a link in the whole chain of mathematics. So I ask you not to underestimate your part in that link, because all the links connect to each other, creating a stronger understanding of mathematics in general. So if a student goes into Algebra 1 with a strong understanding of number relationships through counting and sequences and multiplication and division and adding and subtracting and bits and pieces, algebra is not that hard to understand. Thanks for watching today, and I'll see you in the next video.